Good afternoon to Honorable Dean Sri Tanma Singh sir, our respected HOD and Administrative Officer Sri Rana Chakraborty sir, respected HOD of Mining Engineering Department Shankar Sarkar sir, respected HOD of Electrical Engineering Department Subhatul Goswami sir, and respected HOD of Mechanical Engineering Department Abhishek Mitra sir, and our very special keynote speaker Sri Subhashish Mitra sir. Good afternoon to one and all.
Good afternoon.
Thank you, sir. It has been a great honor to have a renowned speaker like Subhashish Mitra sir this afternoon with us as our keynote speaker of Impact Lecture 2022. At Asansol Institute of Engineering and Management Polytechnic, we believe in impacting the minds of our students. And in pursuit of doing that, in pursuit of instilling academic excellence and other related, qualities in our students, our worthy management, our dean sir, our administrative officer, we all have decided to go for an impact lecture, and this has been and today's lecture is the outcome of that noble initiative. We are going to begin this program with auspicious ceremony of lighting the lamp, and for lighting the lamp, we have with us our dean sir, our administrative officer, and respected HODs. May I request our dean sir, Chakraborty sir, and others to light the lamp and mark an auspicious beginning of this program. Please, sirs. Now, Asansol Institute of Engineering and Management Polytechnic was established in the year 2015 under the aegis of Eastern India Educational Trust. Our Honorable Director Sir, Sri Mitra, and our Principal Madam, Dr. Lisha Mishra, have been a source of perennial support to all our efforts and good works. And they have greatly patronized us to organize Impact Lecture 2022, and we are very fortunate to have Subhashish Mitra sir, the former General Manager, Project in Electrical and Automation, Steel Authority of India Limited, and Center for Engineering and Technology, Ranchi, Jharkhand, with us this afternoon as our keynote speaker. Sir, with your kind permission, may I introduce you to our audience?
Please.
Thank you, sir. Thank you, sir. Sri Subhashish Mitra sir did his BE in Electrical Engineering from Jadavpur University, Kolkata in 1980. And he did his ME in Project Engineering from BITS Pilani in 1983. In course of his career, he had served thermal power plants in DCPL, Kolkata from 1980 to 1990. And in 1990, from 1990 September to 2018, he worked in SAIL CET, where he handled design, engineering, and consultancy services in electrical and automation system, especially in the areas of iron and steel plant. In course of his career, Sir had been to number of foreign countries like Germany, Egypt as a technical expert. Apart from professional uh, excellence that Sir has given to numerous institutes, numerous organizations in his professional career. Music is Sir's passion, if I'm not wrong. Sir, we are really honored to have you in our portal and to get you as our keynote speaker. The session is all yours now, sir. Oh, sir, I'm sorry. Now I request our Dean, sir, Sri Tanmay Singh, sir, to speak a few words to mark the beginning of this program. Sir, please.
Good afternoon, respected Director Sir, Principal Ma'am, Administrative Officer Rana Sir, our Dr. Sanko Sir, HOD Mining, Abhishek Mitra Sir, and Subhadip Goswami Sir, in charge of Electrical and Mechanical Engineering. Today, we have organized a 2 days impact series which has been sponsored by Institute Innovation Council under AICTE. And we are very fortunate that in West Bengal, we are the only polytechnic to have this grant of doing the impact lecture of 2 days. Total, we have 4 dignitaries which will deliver the speech. One has been occurred in the morning, and today, now the second one in the session. And I am very much thankful to the speaker, Mr. Subhashish Mitra, on the topic control, utilization, and management of electrical power. Actually, impact lecture means which will give an impact to the student who have missed their curriculum and knowledge during the COVID. So today we will hear the enriched speech from the keynote speaker, Mr. Subhashish Mitra sir. Thank you. Device sir.
Thank you, sir, for your valuable words. Now, may I request our honored administrative officer and HOD of CST Computer Science and Engineering Department, Sri Rana Chakraborty, sir, to grace the occasion with his valuable words. Please, sir.
Thank you, Devashish sir. First of all, a very good afternoon to our respected director sir, principal madam, our eminent speaker, Mr. Subhashish Mitra sir, our Dean of Academic, Mr. Tanmay Singh sir, all HODs, faculties, students, and the viewers. This impact lecture by our respected Mr. Subhashish Mitra sir will be a great thing for all the viewers. Hope this lecture will help our students or viewers a lot to fulfill the gap which was occurred during the COVID situations. And we are very much glad that these impact lecture sessions are funded by IIC under AICT. So we are very much glad for these lecture sessions. I heartily welcome our eminent speaker, Mr. Subhashish Mitra sir, for his lectures. Hope it will be a great success and will be very helpful for our students. Thank you, sir.
Thank you, sir, for your encouraging words. Now, may I request Dr. Shanku Shaurkal the respected HOD of Mining Engineering Department, to grace the occasion with his words. Please, sir.
Thank you, Devasi sir. Respected Director sir, Principal Madam, and our keynote speaker, Mr. Subhashish Mitra sir. We heartily welcome you to present the keynote address in the Impact Lecture Series, which is organized by Asansol Institute of Engineering and Management. It is special for us because to hear from you, such a person who has huge experience in industry and institutions, which will be certainly have an impact on the students. This will give them some idea about topics which may be within the syllabus or out of the syllabus or extra from the extra curriculum. Thank you. Thank you for joining us, sir. Once again, very welcome, sir, for your presence. Thank you, sir.
Thank you, sir, for your encouraging words. Now, may I request Mr. Shubhadeep Goswami, sir, the honored HOD of Electrical Engineering Department, to grace the occasion with his words.
Very good afternoon, respected Director Sir, Principal Ma'am, Dean Sir, all HODs, Administrative Officer, Rana Chakraborty Sir, and my heartily welcome to Mr. Subhashish Mitra, ex-GM, Steel Authority of India, for the impact lecture on control, utilization and management of electrical power. This impact lecture is totally organized by Asansol Institute of Engineering and Management, Polytechnic, and the second impact lecture, in fact, on the first day is the second session. More two will be organized tomorrow, and it's totally funded by IIC, that is the Institute Innovation Council, and the All India Council of Technical Education. I hope, my dear students, it will be a great thing for you all, because this industry overview is really needed in your forthcoming future, so that you will be enlightened in your future paths. Thank you all.
Thank you, Shubhadeep Goswami, sir, for your encouraging words. Now, may I request Mr. Abhishek Mitra, HOD in charge of Mechanical Engineering Department, to speak a few words.
Good afternoon to Honorable Director Sir, Principal Ma'am, and Dean of Academics and Administrative Officer, and all HOD and HOD in charge. We feel privileged and honored to host this second impact lecture funded by IIC and AICT in our Institute of Asansol Institute of Engineering and Management, Polytechnic. I heartily welcome Mr. Subhashish Mitra sir, ex-GM SAIL, to give his valuable lecture on control, utilization and management of electrical power, so that it might help our students to gain some valuable knowledge which they have been debarred during the COVID situation. I would heartily welcome you to give your lecture and start this session. Thank you.
Thank you, Abhishek Mitra, sir, for your encouraging words. Now the time has come. Yes. Sir, am I audible?
Yeah, you're audible, you're visible. Am I audible and visible?
Yes, absolutely, absolutely,
And
sir.
I wanted to check. Now I cannot find the presentation slides, so I think once you will be make me through, so that I need to finally share, or it is already there uploaded.
Sir, is it uploaded? All the sir's slides are
I
uploaded?
have uploaded.
Sir, yes, sir, it's
Yeah.
uploaded, sir. Yeah,
Okay,
uploaded,
fine.
sir.
Fine.
Okay. So now the time has come, and it's an opportune moment for all of us to listen to our esteemed keynote speaker of Impact Lecture, Sri Subhashish Mitra, sir, who is with us. And we are very thankful to sir for sir's presence in our midst. And Subhashish Mitra sir, the former General Manager, Project and Electrical and Automation, Steel Authority of India Limited, SEL, and Center for Engineering and Technology, Ranchi, Jharkhand. So we hope the session will be a very fruitful one for all of us, and you will be illuminating all of us with your impacting words and slides. Thank you, sir.
That's so. So, may I start?
Sure, sir. Sure, sir.
Very good afternoon to all of you. A big thanks to Asansol Institute of Engineering and Management Polytechnic, respected the directors, the principals, the eminent faculty, um, and the students. Special thanks to the two persons, Mr. Debashish Banerjee, who has been helping me a lot in organizing this seminar, and Mr. Tanmoy Shingho, Dean of Students. I had some preliminary talks for last 2-3 days regarding this lecture session and all. So my topic, see, I am from industry, but I have my first love is definitely academics. So though I have spent some 39 or 40 years in industry, but academics was my first love. So and thankfully I have served two companies. One is development consultant, and one is Steel Authority in its consultancy organization. So in this 40 years, I could not run away from the classroom, okay, or the academics. So I did some consultancy kind of services. So I could not dissociate myself never from the academics. So that I consider to be very lucky. So I had the privilege to interact with students and management students of our sale at large, and various technical sessions and all. So I always find it very useful whenever I get an opportunity to express my views on whatever industry I am serving, and some keywords if I can share, so that I consider to be my good luck. So today's topic, so my basic subject is electrical. So I have chosen a topic that is control, utilization, and management of electrical power, and of course in view of the industrial context, of course. Now you might see that it starts from control. So where is generation? Of course, there is generation. So so I'll start basically from the generation, and I'll start with some very basic things. Not because students are listening to it, because this topic is quite a vast thing. So maybe first few slides, 4 5 maybe 6 7 slides, I'll touch upon the very basics of electricity, which you may find it boring, but I think it is necessary. So I'll start my slide presentation, and I'll be you can interrupt me at any time. So as you can see in this slide, there are three gears. One is generation, one is transmission, one is distribution. So whenever we talk about electrical system, basically it encompasses three areas. One is generation, one is transmission. Generation means we are generating electricity, the producer. And then distribution is the consumers, maybe industry, maybe domestic. And transmission is in between. From the producer to the user, the circuitry is called transmission. It may sound very simple, but it is very complicated. So I go to the next slide. Now, as I told you, the very basics. First, I'll just handle a few words which all of us know. So electricity is a form of energy, as we all know, and it is present everywhere. why I call it, it is present everywhere. You see, it is not only that I have put some words like generator, form of electricity is there. Of course, it produces electricity is produced in generator, other than static electricity, of course. Then motors, industrial, domestic, medical appliances, all electronic and IT hardwares, everywhere it is electricity. Even in human body, we have body electricity. So body electricity and body magnetism, we all must be knowing. So electricity is everywhere, even in our body. Not only to talk about pacemaker, even all our cells are basically electromagnetic cells, and there is a body electricity. So electricity is everywhere, and it has the power to heat, to light, because electricity is an energy. Energy is transferable. So it gets transferred to heat and then to light. It can move things because as you can see, the motors, these are basically electrical energy is transferred to a mechanical rotation. So there are a lot of such things. It can with these motors and with these appliances, you can make things happen. And what are conductors? Conductors are basically metals, mostly, and also water. So that is called conductors. So electricity is nothing but movement of electrons. So for electrons to move, you need some conductor. So as we all know that the direction of electrons and direction of current are reverse. So these are very basic things. I'll just quickly go through, and then if there is electricity, then Ohm's law has to be there. We all know almost, and even non-electrical engineers, we all know Ohm's law. That is nothing but the very simple thing that current is proportional to voltage. So if the voltage increases, current will increase, and it will depend on the resistance or the load. So, and the units current, we all know, almost everyone knows. Unit of current is ampere, voltage is volts, and resistance is in ohms. So if there is we are considering a DC circuit, of course. So if there is a voltage, say 220 volt is applied to a resistance of 10 ohms, the current will be 220 by 10, V by R, so that will be 22 amperes. And it is measured by very simple digital ohm meters or any ohm meters. Now, electrical power, we all know the presence of electrical power. We can feel it because in all every day, whenever you switch on an electrical heater or a toaster, current flows and it gets heated up. Because current flows and there is a resistance, so there's I square into R, so there is power. So that power, electric power, is transformed to heat. And if there is a heating coil, a light also can emit. So power is defined basically the rate at which work is done. So power is the heating effect of passing a current through a conductor. So basic formulas are that power is voltage into current. So if you convert voltage as I into R, so it will be I square R, or power is equal to V square by R. And we all know that unit of power is watt. Now, this is a very DC circuit, but AC circuit is not that simple. AC is alternating current, so where the voltage waveform is not a straight line, it's a sinusoidal. So we all know the meaning of sinusoidal. So it starts from zero, it achieves the positive peak, then again it comes to zero, and then reaches negative peak, and again zero, and it continues. So current waveform is also, it will follow the voltage waveform, but it can lead or lag. So this leading and lagging are issues are basically associated with any alternating circuits. So if you see that next picture where there is a red envelope of voltage, and in the first picture, and there is a current waveform which is basically leading. Uh, Leading means when voltage waveform is zero, that time current is the maximum. So that means current is leading. So it's a case of capacitive circuit where current leads the voltage waveform 190 degrees. One cycle is 360 degree. So similarly for inductance, it is 90 degree lagging. So when voltage is zero, then current is negative maximum. So AC power is VI into cos phi, that is cos phi is a power factor. Okay. Now, again, this AC is not that simple as DC because, because the most popular thing is AC. So, and it handles a lot of power, huge power. So, single phase cannot handle such amount of power because current will be enormous. So, there are three-phase networks. Now, as we know, three-phase can be of two types. Either it will be delta connected or a star connected. So as we go up in voltage, you'll see that delta connected, normally high voltage sides are higher voltages are basically star, because star is the line voltage with respect to neutral. So in case of a very high voltage, suppose a very big transformer, say 220 kV by 33 kV. So 220 kV side normally will be star because the insulation or winding we can put lesser insulation because we can put phase to neutral voltage as a lesser, because so for lower voltage applications, you'll find it is delta connected. Say for a very small motors, three-phase motors of maybe in some few kilowatts and all, and up to say 415 volts or maybe 3.3 kV volt, 3.3 kV. So you'll find the motor winding can be delta, and after that it will be star. So anyway, so these are not very simple electrical engineering. So I have get into some difficult area already, but I assure you this will not be a theoretical electrical engineering class. Very soon I'll be switching to my main topic. So we all handle three-phase power in industry. So single phase in the domestic, of course, we handle single phase in our house. Of course, in our in day to day, you might have seen even in our flat, even in our buildings, three-phase supply comes and it is distributed to three phases. So three-phase is the only solution to handle bulk power. Now, if we had to measure electrical quantity, say there is ammeters, again that a small multimeter can do, or even a tongue tester can do. So if we want to measure power, there are watt meters, and commercial units of power or electrical energy is kilowatt hour, as we all know. That is the unit most important because that is money. So so energy is nothing but power into time. Now, electric power is the rate at which electrical energy is transferred by an electrical circuit. Okay. It is the rate at which electrical energy is transferred. So as I told you that kilowatt hour is energy, so kilowatt into time. So energy is always having a time component in it. So rate of energy will be, that means kilowatt hour divided by time. So electric power is the rate at which electrical energy is transferred by an electric circuit. So you will see that any installed electrical equipment, anything which is installed, the capacity is mentioned as kilowatt or megawatt. when I put it into the circuit, when it is if it is a motor, it runs, it takes power, or current is drawn in from the circuit, so energy is consumed, so that is kilowatt into hour. So but kilowatt hour can never be put in a nameplate, so it is capacity is always the power rating. Okay, and now depending on how long you put that particular appliance in circuit and how much duration you run that drive, so that will decide how much unit will be consumed from the utilities or the electricity authority. So now the basic as a basic power equation is P power is equal to voltage into current. So kilowatt is equal to kVA into cos theta. Now what is that cos theta? As I just now mentioned, this voltage and current waveforms, the current either to lead or lag the voltage. So if it is most of the inductive loads, most of our loads are inductive loads, so current lags. So lagging angle with respect to the voltage waveform is the power factor angle, or the theta. So kilowatt is basically kVA into kVA is the apparent power into cos theta. So that is the real power. So which is the nameplate rating of any equipment. So it is the, if you connect a motor, say a 22 kilowatt motor or a 30 kilowatt motor, so it will draw a real power of kilowatt of 30 kilowatt at a rated load, of course. But since there is an inductance, so there will be a power factor. So some inductive load will also be drawn from the source. So there will be a lagging current. So that also, that current, that component of current will also be there, which will get reflected in the apparent power, and you have to pay for it. Okay, I'll come to it. It's very interesting. So through some vector diagram only it can be explained in a better way. So now reactive power is unused power. Say the example of a motor. Motor is having windings, so it is having an inductance. Now when you are connecting a motor, it is supposed to work, produce a mechanical energy or mechanical output equivalent to the real power, kilowatt, no doubt about it. But to produce that electrical that mechanical output power from the motor, you also need, because the circuit is such that there's a winding, so there is an inductance, so it will also draw some inductive currents, so there will be an apparent power. So apparent power will be a vector sum of real power and the reactive power. So let me go to the next slide. It will be very clear. Now say this the base, the W jahan pe likha hua hai, that is the real power. So reactive power is Q. So apparent power is S. Now see, there is a glass. The glass is having some drinks. So you can see the active power is the actual liquid that it is having, and on top of it there is some froth. Okay, so totally you will see that apparent power is the total length of the glass to which even it up to the level of the froth, but actually the liquid is this much. Okay, so I think I can explain in this way. So what is this power factor then? This power factor, as I told you, the apparent power is vector sum of real power and the reactive power. Now reactive power, we have to pay for the reactive power because the circuit is such, because it is having inductance, so it will draw a part of reactive power from the utility. So apparent power, which is a hypotenuse of the triangle, so you have to pay for it. Now consider if we can generate some reactive power. I am drawing reactive power from the source, but if I add some component which basically, not of course not free of cost, if I add a component which gives reactive power, so apparent power will reduce, because the reactive power that is being demanded from the source, from the utility source, if there is a component like say capacitor which supplies reactive power, so actually the load or the motor will be needing lesser reactive power, so apparent power will be lesser, so current drawn will be less, so your pocket, you need to pay less energy bill. Okay, and if you do that, there will be other advantages also, like if you do not compensate the power factor, then it will draw more current. So more current means more voltage drop. So more voltage drop means more heat. So the motor will get, or the load will get overheated. Motor or any inductive devices. As I told you, most of our devices are inductive devices. So there are advantages. I'll just show you. Say, suppose the real power, if it is 80 kilowatt, and reactive power requirement was 60. So 80 and 60, if you vectorially, if you add, so apparent power will be 100 kVA. Now, if you add a capacitor and supply 30 kVAr, so system will see that it needs to supply only 30 kVA to the load. So the apparent power will reduce. Apparent power will now become say 85.4 or whatever. So it will draw lesser current. Lesser current means lesser electricity bill. Lesser current means lesser overheating. So that's an advantage to any system, for that matter. Now, as I was at the very beginning, I was telling that the electrical system basically having three areas mainly. One is generation. Generation means where there is power station. So power station can be of number of types of power stations are there, where electricity is generated, and then electricity is generated means it has to be taken to the load, that is to industry, and also to the domestics, to towns, cities, villages, whatever. So you have to step up the voltage, because generation voltage, it can be maybe 11 kV, 12 22 kV, 33 kV, but if you have to travel kilometers of distance, so unless you raise the transmission voltage, there will be losses, tremendous losses, because losses, as I told you, that power V is equal to IR, jahan se aaya power se aaya V into I. So if you increase the voltage, the current will be less. So if you increase the voltage level to transfer same amount of power, it will have lesser current. So lesser current means lesser I square into R, so lesser loss. So transmission is always will find it is transmitted at a very, very high voltage. We'll find now 400 kV, 220 kV, 400 kV, even 765 kV, 1050 kV tak chala gaya hai abhi. So in India, so transmission is done at a higher voltage. Now it comes to the distribution point. Distribution can be either commercial, industrial, or business consumers, which handles a bulk amount of power. So there also some voltage, maybe 11 kV or 33 kV is required. And domestic, of course, we need lesser voltage. So because in our household, we all know that it is 415 volt or 400 volts. So domestic, finally, it will come down to 415 volt level. So there are three basic areas. One is generation, one is transmission, one is distribution. And in distribution, there are a lot of automation devices these days for metering and load management. So those things are, of course, maybe today I cannot explain all, everything and every detail of even automation in distribution. I'll try to touch upon. So generation of electricity. Normally, most of our power plants in India till today, we are using fossil fuels. So it is basically a coal-based. So there is a boiler in it. So steam is produced, and there is a turbine. Turbine can have intermediate, main, intermediate, and then there will be condenser. There will be condensate, and finally there will be an alternator or generator. So generator is a rotating machinery. Electricity is generated at normally at a voltage of 11 kV or 33 kV, and then finally it is stepped up for transmission. Transmission takes place 132 kV or 220 or 400, and it goes up and up. So power stations are normally owned and operated by energy companies. Now transmission, it starts from generator transformer as in the previous slide. Then it is stepped up. It is stepped up, as I told you, it is stepped up to 132 kV, 220 or 400 kV. These days, even in West Bengal, there's a lot of 220 kV and 400 kV circuits. 132 kV is almost, in our time, it was considered to be very high. Now it is not that. Now 400 kV is considered to be a very standard voltage. Very high voltage, but it is now almost become standard of our day. Now it is transmitted at that voltage, because for a 400 kV, I just tell you now 132 kV, 220, 400 kV, इसमें difference क्या है? Difference इतना है कि same power, if I want to transfer in these three different voltages, as the voltages goes up, the current will be lesser. So as you increase the transmission voltage, the losses in the transmission line will reduce and reduce. So that is the objective. That transmission losses we have to minimize. Anything, not only transmission. Our objective is in every in a circuit, in every point, I have to reduce the loss. In generation also I have to reduce the loss, in transmission also I have to reduce the loss, and in distribution or the consumers we have to reduce the loss. Because if I save loss, means I'm basically generating. I am saving some money. That means I'm earning, because that much money, the money which I have saved is the money I have earned. So loss I have, if I minimize, that means it is a generation. Direct. Now this transmission line and overhead transmission in India, it is the it is being operated by our national grid, say National Grid Corporation, or that will come to it. State-owned, government, central government-owned, and private players. So now this transmission line, mostly it is National Grid manages this. In state also, there are transmission lines, but even in West Bengal, you will find there are two types of transmissions are there. One is owned by the generating company, and another by NTPC or Power Grid Corporation. Because now a whole of India is now integrated in terms of power generation and transmission. So there are state institutions, and finally there are national level institutions or national level players. That is the backbone through which power flows from one state to another, one company to another company. Now distribution, it is the most this is a huge thing, and distribution is where we all fall as an industry or domestic, whatever. So now you'll find distribution electricity will also be done at various voltages. Suppose a big industry, suppose a steel industry near Asansol, or if the generation, if the demand is quite high, say 40 megawatt or 50 megawatt or whatever, then that company, that factory or that the industry also needs a power at a higher voltage. But if it is a smaller company, maybe a small mill, so maybe 33 kV distribution is sufficient for it. Light industry, maybe 11 kV, 6.6 kV. And now coming to the domestic, you have to give power supply at 400 volt or single phase at 230 volts or 240 volts. So all these industries and homes, basically it is connected to the national grid, but through the local systems, local distribution systems. Okay. West Bengal, we have got WBSCDCL, or in CSC area, we have got CSC. In Asansol area also, there are some private parties. So, what is generation? Generation is electricity, where electricity is generated at the power plant premises by either by some utilities, government utilities, or some independent power producers. Now, from the power plant, from the generating house, it comes to step-up substations, and it goes through a transmission line, and it is the vital link. This transmission line, as I mentioned to you earlier, is the most vital link between the power producer and the power user. The transmission line, of course, it carry the electricity at a high voltage, higher and higher voltage, to reduce the loss. As you increase the transmission voltage, losses will reduce. Of course, if you higher voltage transmission means high cost, of course, transmission line cost will be there, but there is an equation that there is a balance. So now, as I told you, in India, 400 kV circuit is very, very common and very, very standard design. So there is no issue of 400 kV. आज के दिन में बहुत बड़ा कुछ नहीं है. So in our times when we passed out, and 132 kV सुनने से लगता हाँ कितना high voltage है. And in a span of say, a few decades now, 400 kV has become very, very simple thing. So this is another picture, so I need not explain. In this picture, I mentioned that, okay, now the power plant can be of various types. It can be a coal-based plant or fossil fuel-based plant. Fossil fuel means coal or oil or natural gas. Or it can be a nuclear power plant. Or it can be a hydroelectric plant. And then, as you go to the distribution end, you will find other forms of renewable energy sources like solar and wind power. So we'll come to it slightly, because these are solar and renewable energy. Now they constitute quite a substantial energy output of our country, and our dependence on fossil fuels has to reduce. As you know, that our dependence to petrol has to reduce. So like our dependence to coal and fossil fuels has to reduce, and we have to make use of renewable energy resources for the future. We'll come to it. Now, what are the primary energy sources in our country? So it can be finite, finite source. Finite means it has an end. It is not infinite. That is finite. So coal is definitely a finite source because we are, we are in living near Asansol. It's a coal belt. So the coal is not available over years. It has to end. Though we have got a big stock, of course, still it has to. You cannot go on using coal, not only because it will reduce, but there are carbon restrictions are there. Just another big topic, of course, we will not get into that. So the use of carbon means you are generating carbon dioxide, carbon monoxide, and all. So so some way or other, you have to minimize the use of coal. Not only because of it is a finite source. It is going to deplete. It will get depleted over the years, but because of our carbon nuisance. Crude oil, may be available for another 50 years. Natural gas, maybe it will be available for another 50 years. And nuclear, it's a dangerous thing. It has to be used with a lot of safety, lot of precautions. Of course, in India, you are having nuclear power plants, and in Europe, in US, a lot of in Russia, Ukraine, a lot of nuclear power plants. In India also, you have some nuclear power plants, quite a few. So, but it is a bit risky. It has some threats. What are infinite? Hydel. Hydel is infinite because if you can make use of the river and water, so you have basically infinite. Of course, building up a hydro electric plant is very, very costly, and it takes a lot of huge time. Solar is infinite. There is no bar, but it is fluctuating. Not because there's light and shade, there's a cloudy or not. The intensity of solar energy it fluctuates from climate to climate. Wind power is also infinite, but it fluctuates. Anywhere, everywhere, you cannot put a windmill and you can expect wind power is being generated. In India also, wind power, we are trying to do a lot of wind power plants, but there are a few things. You will see that in southern belt, coastal area, in Rajasthan, some of the areas, the wind power are successful. But everywhere, that wind direction and the wind force is not that may not be that helpful. So in Europe also you'll find in a lot of countries wind power is very, very popular, but not everywhere. So it depends on the geography of that particular area. Okay. So tidal is again infinite, but it fluctuates. There are other sources like biogas, biomass, fuel cell, and of course, we are trying to tap all those things. Actually, I'm going to show you some status of Indian power and energy sources these days, even in 2022. So that may be of quite interest to you. These are not only theoretical; they're very, very practical. And I tell you, आज से करीब 30-40 साल पहले power generation in India meant only coal based. And as I graduated and as I joined industry over this last 30-40 years, there is a sea change. Now there are a lot of renewable energy generation in India. It's- I never expected that thing will happen so fast in India. Now, let us see what is the energy scenario by 2030. So there is a very important very important parameter called per capita electricity consumption. This electricity per capita consumption means a person, an individual, how much energy he will consume per annum. Okay. Now, worldwide, the present figure is 2,500 kilowatt hour. Okay. And in India, it is very poor. That means how it's not that how many gadgets I am using, electrical gadgets. Of course, uh, the in my house, how many ACs are working, how many pumps are there, or whether heater is there or not. How much of lighting fixtures are there or not. Of course, everything will contribute to the energy consumption. But in a present modern day society, in European society or a developed country, this 2,500 kilowatt hour considers to be a standard. Okay, whereas in India it is very less. In 2010 it was something around 500. Now in 2020 it is around 1,200 kilowatt hour. Now in 2030 we expect to touch maybe the global, near about the global. So it shows how developed we are. I am consuming more electricity in my house means I am having a lot of gadgets. So I am in a developed society. That it means that as we industrialization takes up, and you will be using a lot of appliances, particularly this heating and cooling. That is very that consumes a lot of electricity. So by 2030, 22 किलोवाट आवर एनर्जी इलेक्ट्रिसिटी कंजम्पशन होगा, मतलब हमको पावर जनरेट करना पड़ेगा ना उसके लिए. Because if we are to develop, like our society is developing, so most of us are now using those who are using two-wheelers. Now they are planning after they get a good job, so let me have my four-wheeler. Okay, that means you start consuming petrol. So like that, electricity consumption has to increase as the society gets the level increases, comfort level and other things, of course. So let us see where we stand right now. Now in 2012, it was something around 914. So it started increasing at around 2020. It was around 1,200. And it's going up and up and up. It's good. It has to increase. That means you are in a society. You are in a service. Your buying power is increasing. So earlier you had one AC. Now maybe after 5 years you consider no, I should have another AC. Maybe the whole flat of yours should be air conditioned. So you will start consuming electricity. So that is an index of how society is progressing. Okay, how you are developing. So this energy consumption has to increase. Okay, there's no doubt about it. Okay. So we'll get into some data once again. Now, what is power station? As I already explained, power station is basically a generating station. It has a facility to generate electric power. So each power station will have one or more generators, which is a rotating machine, which converts mechanical power to electric power by creating relative motion between magnetic field and a conductor. That we all know. So now, mostly our power stations where are using fossil fuels like coal, oil, natural gas. We also use nuclear power, and there are increased use of renewable sources like solar, wind, tidal wave, hydroelectric. I will not get into great detail. Fossil fuels, उसमें क्या रहता है कि there is a coal-fired boiler, steam is generated, and steam turbine is driven, and the generator then produces electricity. Waste products like ash, sulfur dioxide, nitrogen oxide, these are removed from the waste to reduce pollution. So, of course, pollution norms are quite stringent. Fossil fuel power station has got issues. Nuclear, as I told you, that is very efficient, but a lot of you have to use it with a lot of care. We know what a nuclear power plant devastation it can make if there is some issue. Geothermal power plants, not very popular. From underground hot rocks, steam is extracted. Biomass fuel power plants, waste sugar cane, municipal solid waste also banta hai. In our steel plants, we use blast furnace exhaust gas, which is a low cost, low energy density fuel. So we use that fuel as a byproduct we get, and we generate. Then from industrial processes, we do a lot of waste heat generation. Solar thermal, basically we use sunlight to boil water and then it produces steam. It's also kind of solar, you can say, but it's the solar energy is absorbed to heat up and to produce boiling water, and then it produces steam. Simple electric generator, I'm not going into it. These are, I think, all basic electrical engineering persons or the students, they know. So there is if there is a magnetic field, if there is a rotation, so you know what happens. So whether it's a generator or whether it's a motor, there are Fleming's left rule, right rule, everything we know. So this is a kind of modern generating system where these yellow ones are the turbines, and on the left hand side there are alternators, exciter and all. It's a steam generating type power plant. And an outside view of a modern power plant, fossil fuel based. The control room. So as I was mentioning, so in thermal power plant, fossil fuel power plant, there is a boiler and fuel is added, that is coal. Coal is pulverized, coal is burned, and then smoke and the fly ash comes out of the boiler, and then steam is taken to the turbine. Generator is rotated and electricity is generated, and from the turbine the exhaust steam, which is at a low temperature and pressure, it passes through a condenser, and condenser is cooled by pumps, condensate cooling pumps, maybe from river, and then the condensate water is fed to the boiler once again through boiler feed pumps. So this is a cycle. This is how fossil fuel based power plant operate. This is a picture of a super thermal power plant in Rajasthan. These are some power plant pictures. Now, what are the major electrical equipment in a power plant? We know the generators are there. Generator में rotor होता है, stator होता है, exciter होता है. I will not get into great depth of it, though these are my favorite areas, but in today's topic, otherwise it will become a huge topic. So after generator, the generator bus duct will be there. Power will be taken through bus duct, through neutral grounding equipment to generator transformer. and this generator transformer is stepped up for the transmission voltage. So other than that, for in the power plant, there will be a lot of other transformers like station transformers. For lot of auxiliaries are required in a power plant. The generators need for power plant to generate power. It has to run a lot of auxiliaries. So for that, a lot of electrical drives are also required. So you need electrical system. So there will be EHV switches for evacuation. There will be a lot of transformers. There will be protection. Generator protection is very important. Generator control and metering equally. There will be PLC based automation everywhere. There will be synchronization and islanding of the power plant because it has to be synchronized with the grid. There will be SCADA system for control. So like that. There's some basic electrical signal line diagram. I'll not get into these details because otherwise we cannot finish. This is a photograph of a generator bus duct. So generated power from the generator is taken to the generator transformer through this bus duct, this aluminum bus duct. This is a generator transformer, which is a very critical item of a power plant. From the generator transformer, it is stepped up to transmission lines. Now, very interesting. ये जो दिखा रहा है ये मोटा मोटी 2015 का है, 2022 का भी हम दिखाएंगे. What are the sources of electricity in India by installed capacity? Now we will find the biggest chunk is in this is a 2015 data. And after that, I will show you the 2022 data also. So coal based power plant was around 59%. Okay, so majority is coal based. Hydroelectricity is around 17%. Renewable energy source, that means solar and wind power and all, only around 12%. Natural gas, not much, 9%. Nuclear only 2%. India ka hai ye. And oil based, very critical. I mean, very whenever it is very essential. Only otherwise oil जला के generate करना is very uneconomic. Okay. So this was the scenario in around 2015. Now you see. This is May 2022. The total installed capacity of India is now 402 gigawatt. That means 400,000 megawatt. Okay. इसमें coal around 204 gigawatt. That means around 50%. It is still 15%. But you will find the RES has now become 113. That means solar, solar and wind ये सब मिला के पहले वाला दिखा था एक बार आपको. और रिन्यूएबल एनर्जी सोर्स जो कि 12% था वो अभी 7 साल में now it has become 113. That means it is almost 25%. That means in a span of 7-8 years, renewable energy sources, say power generation in India has increased like anything. We may not be aware, but this is very slowly. I never expected that this solar power in India is going to increase in this pace. Even in this COVID period, एक साल में थोड़ा सा डिप हुआ था, but again it has India का जो power scenario है, particularly renewable energy sources में काफी तरक्की हम लोग किया है. It is unthinkable. I never thought in 10 years back We thought we'll still continue to burn the coal and like that, and some hydel will say is lot of costly, very costly. So let us burn coal only. Gas based का भी अपना limitation है because we don't have that much of natural gas. But solar and other renewable energy sources में India is doing havoc. Like we never thought that this petrol crisis में जो हुआ है कि ethanol will be added and now 10%, 20% जो भी चल रहा है, we never thought कि इतना बढ़िया से होगा सब कुछ. But it is happening in power sector in India. We'll find that renewable energy sources are increasing and diesel is decreasing. That is good. Now you see, this is the latest data from CEA, 31st May 2022 का. Fossil fuel coal around 50.7%. उसमें lignite बहुत कम है. Gas only 6.2%. Diesel only 0.1%. That is desired. So total fossil fuel is around 58%. And renewable energy is 39.7. Out of that 39.7, you'll find that hydro is 11.6, wind, solar and other renewable energy is 28%, जो कि 2015 में था 12%. 12% has become 28%. So we are India is really doing great job in finding out avenues to use solar and wind and other renewable energy sources. It's really great. Now let us see install capacity. अभी इंडिया में अभी है 402 gigawatt. That means for around 402,000 megawatt. Out of that, central government is having around 100k. Red one is state sector is around 100k, and yellow one is private sector. That's great. So private sector power plants now is more install capacity wise. It is around 200. It's around 200,000 megawatt, whereas central government, that is NTPC and all, उनका around 100 है. State government का सब मिला के 100 है. So private sector में power plant power capacity is now almost twice. Okay. Now you can see in this slide also, central sector is 99,000 or 100,000, which is around 25%. State sector 104, that is 26%. Private sector 49.4%, that is around 50%. आधा private sector में, which is unthinkable in आज से 25-30 साल पहले. Everything was with the central sector and state sector. Now participation has increased and a lot of power plants are coming, because our final target is per capita consumption को बढ़ाना है. अगर हमको developed country बनना है तो मेरा consumption बढ़ेगा. Consumption घटा के आप developed country नहीं हो सकता है. अगर आपका lifestyle improve करना है तो आपको consume करना है electricity. ठीक है. So this is the total generation over the years. In 2019, if you see total generation, it has increased in billion units. 800, 850 ऐसा करते करते 2020-21 में जो कोविड पीरियड में थोड़ा सा डाउन हुआ है, उसके बाद फिर अगेन 2021-22 में अगेन we have started growing. Growth of total generation, देखिए 2009 से growth was 7.15 कभी 5. So it was 2020-21 में कोविड पीरियड में there was a dip in a year. Again now we are right on track. around 8% growth in 2021 में. So that's fantastic. So power scenario in India is quite encouraging. There's a Hydel plant, Indira Sagar Dam. As I told you, the Hydel power plants are very good, but only thing is it takes up a lot of. You have to put a lot of money into it, very costly, and it takes a lot of time to construct. This is another Hydel plant. This is a nuclear power plant. Now, where do we stand in consumption of electricity in India? You may get some surprises. Who is heading the list? Yes, Maharashtra. Maharashtra is heading the list. Consumption of electricity. Top 5 states of India. Top is Maharashtra. And then महाराष्ट्र के बाद होगा this 195 Gujarat. महाराष्ट्र के बाद होगा Gujarat. Don't go by this percentage. These are growths. So top consumption सबसे ज़्यादा electricity consumption सबसे ज़्यादा है महाराष्ट्र. उसके बाद है गुजरात. Then probably तमिलनाडु है, कर्नाटका है, उत्तर प्रदेश है. ईस्टर्न रीजन का हालत उतना अच्छा नहीं है, एकदम लास्ट में भी नहीं है. वेस्ट बंगाल का जैसे यहाँ पे है इट्स अराउंड 132,619. सो वेस्ट बंगाल का पोजीशन होगा अराउंड 10th, ऐसा कुछ पोजीशन होगा. ईस्टर्न रीजन में वेस्ट बंगाल अभी भी सबसे ज्यादा जनरेशन है, उड़ीसा है, और बाकी वेस्ट बंगाल से ज्यादा मध्य प्रदेश है, छत्तीसगढ़ है. ठीक है, मध्य प्रदेश छत्तीसगढ़ का जनरेशन इंस्टॉल कैपेसिटी वेस्ट बंगाल से ज्यादा है. ओके, बिलीव इट और नॉट. So this is the situation. So renewable sources of power, solar power, wind power, this is a very important and relatively inexpensive source of electrical energy. I think you agree. Inexpensive source because solar सूर्या लोग का तो कोई पैसा नहीं होता, लेकिन the equipment, the photovoltaic cells and the electrical items and all, there are a lot of synchronizing equipment. Of course, solar power plant बैठाने के लिए cost है, but the source, energy source is inexpensive. Now, another very important point, the next point, as you can see, it's being used even in grid-connected situation as a way to feed low-carbon energy. Okay, now solar power, whether it is solar power or wind-connected power, normally it is, these plants are now connected directly to grid. Whenever there is some generation, it feeds, it gets, it's fed to the grid. And as you add power to the grid, that means it reduces the consumption of fossil fuel. So low carbon energy को आपको जो low, otherwise अगर आप directly grid में नहीं feed करते तो आपको fossil fuel को जलाना पड़ता. So and you are using this kind of power, it is definitely a very low carbon energy. You're not burning oil or gas, coal or oil. Okay. Now, in Indian scenario, this slide is slightly tricky. Sunny days in a year is around 300 out of 365 days. So reception of solar power around 5,000 trillion kilowatt hour. Daily average solar energy is around 4 to 7 kilowatt hour per meter square. Efficiency of photovoltaic modules is only 10 to 11%. So but still, this is 1,000 times more than domestic electricity demand projected for 2015. So we have to make use of this. We receive so much of solar energy, so which is definitely 1,000 times that our demand is projected for 2025 or 30. So we have to make use of this solar energy. लैंड रिक्वायरमेंट 1 किलोमीटर स्क्वायर में आपको 20 से 60 मेगावाट तक का भी आप जनरेट सोलर पावर प्लांट बैठा सकते हैं. एंड कॉस्ट अगर देखेंगे तो 4.5 to 5 अगर आपको आएगा कोल बेस्ड में, तो पीवी टाइप बैठाने से आपको 18 रुपया पहले होता था, आजकल काफी लो हो गया, 6.5 to 7 में मिल जा रहा है. सो कमर्शियल सोलर पावर प्लांट में जब तक हम 5 रुपया पर यूनिट में ले आ पाएंगे, सो दिस विल डेफिनेटली बिकम वेरी कॉम्पिटिटिव. And India is moving towards that direction. The generation cost through solar power has reduced in few years time. जब से शुरू हुआ था 2010 के बाद से जो शुरू हुआ, 10-12 साल में काफी जनरेशन कॉस्ट इसका घट गया. Constants are there solar का, no generation during night time. Power capital, land availability is low. Weather may be cloudy or raining, yes. It is not that constant. So grid connected system जब है लगा हुआ है, उसमें पावर मेरे को जनरेट हो रहा है, ग्रिड में जा रहा है. So I am my total power demand on coal fossil fuel based power plant is reducing. That is the advantage. Okay. So area which receives good amount of sunlight which are suitable, ये मेरा constant है, सब जगह पे नहीं होगा. चेरापूंजी में जाके आप सक्सेस नहीं होगा. Large area required to install a solar plant, right? It has got a low efficiency because 10 to 12% is final efficiency. But that is वही thermal power plant की efficiency कितना है? So let us not go by that. Maintenance cost of solar panels is high. Of course, there are some you have to regularly clean it. Dust cleaning होना है. Cleaning is difficult also. So normally solar energy, how it works, you all know there is a solar panel, sun rays fall into it, there is a charge controller, there is a battery, inverter, and then AC load. Or it is like this. The solar panel के ऊपर sun rays fall, and then it is normally DC current produce होता है, and that is stabilized, and then it is inverted. Inversion करके fuse box के through grid connection, metering के through grid में connected होता है, and you can off grid भी कर सकता है. You can charge the battery, and then maybe in night time you can generate from that. Wind power is also similar flow of wind direction. A turbine is rotated. There is a gearbox, there is a generator, then there is a frequency converter. Frequency converter से transformer देके then electrical network में finally it is connected. So wind power's connection is like this. A better view. Same एकदम same नहीं है. In wind power, the direction, the direction it rotates, or the speed, AC is generated. Unlike PV cells in solar में DC is generated. In wind power, we get a AC, no doubt about it, but that is an unstable AC. So that unstable AC को stable करने के लिए again we have to rectify करना पड़ता है, AC DC करके again DC to AC invert करके then we stabilize it. So there are hybrid systems where solar is also there, wind is also there. Both are connected up. This is called hybrid power system. These areas individually, एक area बहुत बड़ा area है, so it is not. I'm not going into detail of it. These are some wind power, some photographs in India. This is India's first 1 megawatt canal top solar power plant in Gujarat. Okay, such things are coming up. Such things in West Bengal are also coming up in over canal top. Yeah. So that old slide, as it was in 3-part: generation, distribution, and generation, transmission, and distribution. So generation part is over. Now I'll quickly run through. Most of the difficult areas now are over. So transmission, as I was telling, loss in transmission is around 4 to 6%. So you have to. The only way you can reduce the loss is by using higher and higher transmission voltage. As I told you, now this 400 kV we are using, and 765 kV DC is also there, and 1050 kV is also we have started. So transmission losses we have been able to reduce to a great extent in India. In India is doing very great in power transmission and distribution, particularly in power transmission. The loss in distribution, that means we are there. Distribution means industry. Distribution means we, the domestic consumers. So we are the culprit, basically. The industry and the domestic, where we have to reduce the losses. ट्रांसमिशन लॉस तो हम लोग घटा दिया है, बढ़िया टेक्नोलॉजी लगा दिया है, 400 के भी कर दिया, लॉस एकदम मिनिमाइज हो गया. जनरेटिंग सिस्टम में भी तो जैसे ऐसे दिखाया कि वी आर यूजिंग बेटर टेक्नोलॉजीज, सो लॉसेस आर रिड्यूस. लॉस जो घटाना है दैट इज इन डिस्ट्रीब्यूशन. ठीक है, सो हम लोगों को करना है वो चीज. तो ट्रांसमिशन सिस्टम में क्या क्या है वो हम अभी आज इतना नहीं बताएंगे. इफ मे बी सम अदर सेशन, इफ अगर हम ट्रांसमिशन जनरेशन में कुछ कभी मौका मिलेगा तो उसमें बात करेंगे. तो इट्स अ बिग सब्जेक्ट, सो माय फेवरेट सब्जेक्ट आल्सो. So just to give you some outline, ट्रांसमिशन सिस्टम में सबस्टेशंस होता है, स्टेप अप और स्टेप डाउन सबस्टेशन होता है. जनरेटिंग स्टेशन से स्टेप अप करना पड़ता है, एंड देन डिस्ट्रीब्यूशन एंड में आने के बाद हमको उसको स्टेप डाउन, दोबारा उसको स्टेप डाउन करना पड़ता है. Now these substations can be air insulated type or gas insulated substation, which is the state of the art now. Presently we are using gas insulated substation in India. But a number of substations we have installed, because gas insulated means it is very safe, very compact. You don't require, very minimum space is required, and it is extremely safe. Okay, so this is basically in India, this transmission and distribution substation, this GIS, gas insulated substation, has changed the scenario of our electrical distribution system. So very compact. So that's a specialized area. In future, if you are interested, sometimes I can talk on that also. Service subject by itself. Okay, now transmission line towers, lattice type towers भी होता है, जो normally you will see, जो भी towers देखते हैं lattice type tower होता है, structural steel का, और एक monopole type भी होता है. So and then we have got cables. अभी extra high voltage cables भी है, even up to 220 kV now cables are there, underground cable, or you can take overhead also. सो केबल के थ्रू भी आप कर सकते हैं, ले सकते हैं, ट्रांसमिशन कर सकते हैं अप टू 220 केबी। जैसे अभी सिटी में आपको मुश्किल है, सिटी में ट्रांसमिशन लाइन ले जाना मुश्किल है ना टावर से, सो आपके केबल से आपको ले जाना है। और डिस्ट्रीब्यूशन सिस्टम में क्या है, स्टेप डाउन सबस्टेशन होना है, जहां पे आपको लोड एंड में पहुंच गया है कि लोड या कंज्यूमर के पास पहुंच गए, तो आपके पास स्टेप डाउन ट्रांसफार्मर सबस्टेशन रहेगा। वहां पे भी आपको एयर इंसुलेटेड हो सकता है, गैस इंसुलेटेड सबस्टेशन भी हो सकता है। देन मीडियम वोल्टेज सबस्टेशन होगा, एलटी सबस्टेशन होगा, एलटी डिस्ट्रीब्यूशन सिस्टम होगा, एंड देन आपके पास और भी कुछ चीज होना चाहिए, लाइक स्टैटिक कॉम्पेंसेशन सिस्टम, आपके पास सर्ज एंड लाइटनिंग प्रोटेक्शन, अर्थिंग सिस्टम होना चाहिए टू सेव फॉर अ सेफ सिस्टम, एंड कंट्रोल प्रोटेक्शन मीटरिंग ये तो होना ही है, और एनर्जी मैनेजमेंट सिस्टम जो आज का दिन में बहुत ही वैल्यूएबल एक चीज है, जो कि एनर्जी मैनेजमेंट सिस्टम, यू नीड कंट्रोल एंड मैनेजमेंट ऑफ द एनर्जी। आप जो भी कंज्यूम कर रहे हैं पावर, और हम बोले कि वी आर इनकरिंग लॉट ऑफ लॉसेस इन आवर डिस्ट्रीब्यूशन सर्किट, ओके। तो until unless you have a monitoring system, how can you find out who are the basic culprits, कहाँ पे लॉस हो रहा है एक्चुअली। तो उसी लिए द एनर्जी मैनेजमेंट सिस्टम हैज बिकम, और a SCADA based system has become the most necessary thing to control and to optimize the power consumption, okay. And why this is important, from next few slides जब जाएंगे उसमें clear हो जाएगा। This is a lattice type transmission towers which you all we know, okay. This is a transformer. Now, a very important aspect. What is this industrial tariff? Because ultimately, what we are all concerned is about the money. How much money we have to pay? I mean, I am consuming electricity. How much money I have to pay? That is being decided by the respective distribution company, which is called a tariff. Tariff means the rates, electricity rates. Okay, so there is a tariff structure in India or in everywhere. There is a structure all over India. Almost all the power distribution companies they follow more or less the same tariff structures. What are that? So one is maximum demand charges. Suppose आपके घर पे 10 किलोवाट लोड है, तो 10 किलोवाट लोड है, आपको डिक्लेयर करना पड़ेगा। तो 10 किलोवाट से ज्यादा अगर आपके पास कभी आप पावर ड्रॉ करते हैं, यू हैव टू पेनलाइज, यू विल बी गिवन अ पेनल्टी। हम घर के लिए हम बोल रहे हैं, ऐसा नहीं है, इंडस्ट्री में होता है ये ऐसा ही कि देयर इज अ मैक्सिमम डिमांड, जो आपको मैक्सिमम डिमांड चार्जेस जो आप कॉन्ट्रैक्ट करेंगे इस कंपनी से कि मेरा फैक्ट्री में इतना मेगावाट मैक्सिमम डिमांड होगा, वो आपको बताना पड़ेगा। सो उसके लिए आपको तो फिक्स चार्जेस देना पड़ेगा, क्योंकि दैट मीन्स on any particular day you may not draw that maximum demand every day, but the day you demand that, the utility authority has to make arrangement for it, so they will charge for it. So if you have got a 20 megawatt maximum demand, so आपका contract demand के हिसाब से एक fixed charges होगा। and energy charges, जितना एनर्जी आप कंज्यूम कर रहे हैं उसके हिसाब से पर मंथ जो बिलिंग पीरियड होगा उसमें आपको उतना पैसा आपको देना पड़ेगा। पावर फैक्टर पेनल्टी और बोनस रेट, इफ योर पावर फैक्टर इज लेस देन अ पर्टिकुलर वैल्यू, ओके, देन यू विल बी पेनलाइज्ड, और इफ योर पावर फैक्टर इज improved, or if it is more than a particular value, that they will give bonus. So that is the importance of power factor, which I was describing at the very beginning of this thing. Then fuel cost adjustment charges, because now there are a lot of increasing fuel expenses है, तो उसके लिए भी एक charges additional होता है. Electricity duty charges with respect to units consumed. There are slabs. Suppose up to a particular consumption in a month, they will be charging this much. उससे ज़्यादा अगर हो जाए वो slab में, तो आपको दूसरा rate से charge करेगा. These are all penalties, so that you are not so that you are optimizing your load. मीटर रेंटल्स होता है, मीटर का एक तो रेंट देना पड़ता है, ठीक है. लाइटिंग एंड फैन पावर कंजम्पशन इज ऑफन एट हायर रेट्स, लेविड समटाइम्स ऑन स्लैब बेसिस, जो आई टोल्ड यू. टाइम ऑफ डे इन सम ऑफ द डिस्ट्रीब्यूशन कंपनीज ऐसा है कि आपको रात को 10 बजे के बाद 10 बजे से 6 बजे का जो होगा ना, उसमें आपको थोड़ा डिस्काउंट देगा. नॉर्मल इंडस्ट्री में, डोमेस्टिक में नहीं होता है. तो एट पीक आवर्स आपका चार्जेस एक होगा, जब ऑफ पिक में आपको रेट कम बढ़ेगा. दिस इज टू गिव यू सम इंसेंटिव कि आप ऐसा टाइम में फैक्ट्री चलाइए, so that the effect on the system is minimized. Okay. Now power factor basics हम पहले भी बताए थे कि so power factor is so it is so important that unless you improve the power factor, you are going to be penalized directly and indirectly. If you cannot achieve that power factor, आपको penalize तो होगा ही. और if you can achieve your good power factor, your apparent power will be lesser, so you will be drawing less current, so directly you will get a benefit. Your kilowatt hour consumption will be less, so you will be consuming less electricity. This is direct. And another is, if you operate at a lower power factor, you will be penalized. If you operate at a good power factor, which is already specified by the utility company, so you will be given bonus. So these are all direct benefits. Okay. So we have to, whether in domestic, in our household also, we must improve the power factor. What is it? That means how to improve the power factor? आपको क्या करना है? देखिए, एक तो है कि आपका the type of जितना भी rotating equipment होता है, whether it is a fan or a compressor or anything, all rotating equipment are poor power factor contributors. Okay. It is not lighting fixtures, or these are all high power factor. So domestic में भी power factor आपको improve करना चाहिए. So compensating devices are there. But in industry you have to. It is such a value it contributes, because in industry most of your equipment are rotating. Either it is a motor or pump, anything, whatever in industry, whatever is you see, all are inductive loads mostly, and it is huge. So you have to have some power factor improvement devices. Otherwise, it is a national loss. It is not. It's loss that not only you are incurring, the company is incurring. It is a national loss. Your reactive power is getting lost somewhere. You cannot make use of that. So this reactive power has to be compensated in industry as well as in domestic. The domestic में जैसे बोले, domestic में बहुत ज़्यादा नहीं होता है कि आज के दिन में आपको जैसे AC लो पावर फैक्टर है, बट इन्वर्टर ड्यूटी सब कुछ आ गया अभी. So इन्वर्टर ड्यूटी है तो उसमें ऑलरेडी पावर फैक्टर को कॉम्पेंसेट कर दिया जाता है. सो डोमेस्टिक में उतना ज़्यादा पावर फैक्टर इम्प्रूव करने का रास्ता नहीं है, बट स्टिल there are some ways, but effect is predominant in industry. So this is one small example I have given how much if you improve the power factor, then what effect on the system it comes. Another important thing is our demand response. So grid operators means the power plant utilities, either center or state or private. ग्रिड जो ऑपरेट कर रहा है उसका पीक डिमांड को मीट करना है विद द अवेलेबल रिसोर्सेस, क्योंकि आपका जो डिमांड है, डिमांड इज फ्लक्चुएटिंग. कभी आपको शाम को जो डिमांड इंडस्ट्री में या कॉमर्शियल इसमें बढ़ जाता है कहीं कहीं, बट ऑफिस लोड घट जाता है. इंडस्ट्री में नॉर्मली दिन में डिमांड ज़्यादा होता है, रात में कम हो जाता है. सो हाउ इट इज बीइंग ए डिमांड रिस्पॉन्स को देखते हुए द ग्रिड ऑपरेटर्स हैज टू control the peak demand. Okay, so if load increases, you have to build generator, you have to build transmission, you have to build distribution. If you consume less, you have to curtail during critical peaks, you have to shift the consumption or self generator. Shift means suppose एक सिटी में हम देखा गया कि मेरा एक पर्टिकुलर स्टेट में जनरेशन उतना अच्छा नहीं है. सो बट हम क्या करेंगे, भी पावर क्या दूसरा स्टेट से लेंगे, काफी पैसा खर्चा करना पड़ेगा. सो व्हाट वी कैन डू इज आई कैन गिव सम रेगुलेशन हम जारी कर सकते हैं कि भाई आप बोल सकता है कि भाई कोई एक फैक्ट्री में हम बोल सकते हैं कि सुबह में आप ऑपरेट करिए तो आई विल चार्ज यू लेस. उसको शिफ्ट कर दिए 6 घंटा 8 घंटा का अलग अलग करके. जो 3 शिफ्ट ऑपरेशन होगा उसमें आप कुछ नहीं कर सकते. But then by doing this adjustment, you can manage with the whatever power you are having in your state or your the grid operators are having. Otherwise आपको प्लांट बढ़ाना पड़ेगा. It is not prudent ना कि आपको suddenly आपको कुछ तो load, if there is a load growth, then definitely you have to increase generation. Otherwise, because of some issues, some failure of some generator, you cannot take power from somebody else. So you have to give a lot of money for it. So this management, not only load management, generation management is also another thing. So finally, I've almost come to the end of my presentation. See, we have to optimize the energy consumption. So how do we do that? One is avoid wastage. Operational need आपको जो है वो है. Suppose you are running a factory, आपका operational need है, आपको ये चलाना है. So you cannot stop that. So बिना ऑपरेशनल नीड को सैक्रिफाइस करते हुए, if I can avoid wastage of energy, that is what we are looking at. So how this energy can be saved? Very simple methods are there, very simple, and this can be done even in our domestic or in a household also. Avoid wastage of energy. How? जैसे हम लोग पानी में भी बोलते हैं ना, पानी का नल खुला मत रखिए. सो घर में भी आप देखे होंगे कि आप काफी हम लोग वेस्टेज करते हैं कि पंखा चला के रखते हैं, कि लाइट भी जरूरत से ज्यादा करते हैं. Improving efficiency of the equipment, as you all know, this LED culture, जो इंडिया में LED कल्चर तो पूरा लास्ट 10 साल में हो गया. Basically, we are improving the energy efficiency of the fixtures. Earlier it was fluorescent lamps was there, उसके पहले incandescent lamp was there, then CFL came, now LED came. Basically, you are improving the efficiency of the equipment. For a lumen output, now LED requires least wattage. Okay, so this is the reason LED have become so popular, because by using LED, our energy scenario has improved to a great extent, and that you will find everywhere in domestic, in your society, in your city, in your mahalla, everywhere you will find LED use करने से क्या क्या हुआ है. And selecting an equipment for operating close to unity power factor. Now you must have all noticed now these days you will find AC with smart inverter. Okay, fridge, it has come with smart inverter. What is a smart inverter? Now, whenever the equipment which are normally designed to operate continuously over hours, so if you can slightly improve your power factor, so that will have a tremendous effect on your energy. The equipment which are which operates which are designed to operate continuously, उसमें अगर आप power factor if you can improve a bit, it will give you a lot of advantage, lot of फायदा in the money and also the power scenario. Another point is more use of renewable sources of energy. So we have to look in some avenues of use of solar power, wind power. One thing could be, suppose in your building, in my building, say, I'm staying in a building where some 8% stay, flats, the 4-story building. Now, and in the top, on the terrace, if you can think of putting a structure, a permanent structure, and put some solar panels there, so that will give you two good effects. One is if I cover it up, then top floor में जो इतना गर्मी होता है समर में वो भी बंद हो जाएगा, जो शेड्स आ जाएगा, प्लस आई विल बी जनरेटिंग solar PV cells से. And if I make it a grid connected system, so grid connected system से grid में लग जाएगा. So मेरा जब होगा power generation होगा, it will be fed to the grid. So our consumption of our society, जो हम लोग जो building में है, it will reduce. Plus हम 4th floor में top floor में हम गर्मी भी नहीं रहेगा. ठीक है. So now this is becoming very popular. And people are lot of private operators they are offering, because if we the solar plant अगर लगाएंगे घर पे भी तो they give lot of subsidy. Government gives you lot of subsidy. So this is becoming very popular. Okay. So this way we can do havoc. Yeah. Maximize use of LED lamps, as I told. Use of smart inverter duty appliances, as I told, that smart inverter duty appliances are initially people were thinking कि भाई ये तो प्रोडक्ट जो बनाता है सब LG सैमसंग जो भी है वो सब बोलता है कि भाई बहुत इन्वर्टर ड्यूटी स्मार्ट ड्यूटी लिख देता है और वो बहुत कैची लगता है, चलो भाई हाई फाई है, उसमें थोड़ा पैसा ज्यादा है, बट एक्चुअली इट इज नॉट लाइक दैट. I've started I have watched, because I have purchased some smart AC, and I have noticed it that its consumption is definitely it is less if you operate continuously. Suppose आप कोई AC चलाएंगे, आप आधा घंटा चला के बंद करके रख देंगे, उसके लिए नहीं है. जो आपको कंटिन्यूसली जो चीज चलाना है, लाइक फ्रिज कंटिन्यूसली चलेगा, उसमें आप स्मार्ट इन्वर्टर ड्यूटी लगाइए. So it will operate at a very it will have depending on the heat load, its speed, it will adjust, so power factor will be optimized. So your current consumption, power consumption will be less. And another thing in industry, you must have those will be students will be going to industry very soon. You will find that lot of one thing is being used everywhere now. For speed control, you use variable frequency drive or variable frequency AC drives, where you are changing by changing the variable voltage and variable frequency for constant torque application or even constant voltage application, proportional voltage application, you can for a you can operate the motor, operate a drive at the required speed at the optimum power factor. Almost you can say it's unity power factor by adjusting the frequency or by adjusting the torque and voltage. Okay. So by using this VFD drives or AC drives, you can almost reach at a unity power factor regime. So that is operationally required because speed control करने से तभी आप efficiency of a mechanical system, overall efficiency of a system आप speed control करके ही कर सकते हैं. अब वो स्पीड कंट्रोल पहले जैसे करते हैं हम लोग वोल्टेज कंट्रोल करके सिर्फ करते थे, या डीसी में हम लोग रेजिस्टेंस कंट्रोल से करते थे, बट डीसी हैज बिकम ऑलमोस्ट सो मेंटेनेंस प्रोन. सो एसी ड्राइव को कंट्रोल करने के लिए, स्पीड कंट्रोल करने के लिए यू हैव टू control both frequency and voltage, and by making this VYF constant as a application you can this VFD drives you can operate, and you can get almost a near unity power factor regime. So these are basically a few things which are basically in future we have to consider. Why I should say future? These are being considered since last so many years, and that is why the power situation, the power parameters as I have described, and the development that has taken place already in last 10 years, it is so fantastic. So all because of this. Things are happening. We may not appreciate that sometimes, but I find from the various parameters, these are all national parameters. These are not that I have got from some this thing. These are all CEA, Central Electricity Authority or Power Ministries data. Now, Energy Star rating. This is not a very new thing. As we all know, this 2-star, 3-star, and all. This is also basically the same thing. The Bureau of Energy Efficiency, BEE, statutory body. It was formed in 2002 under the provision of Energy Conservation Act. So one of the regulatory functions under this act is to develop the minimum energy performance standard and leveling. So what was that leveling? 1 star for the least energy, and going up to 5 stars for the most energy efficient. We all know as the star ratings are higher, the equipment will be costly, and no doubt, but in some cases it is worth, I must say. For say fridge, it is worth to go for a 4-star 5-star, because it is 24 hours 365, it is online. So whatever improvement in your operational efficiency and power factor is taking place because of this energy rating, it is worth by investing more during the purchase of that particular appliance, because in 2-3 years time from your purchase, you will get back the money. Okay. So the conclusion: electricity saved is electricity generated. So whatever amount we save, it is as good as it is generated. It's like I saved some money, so I earned some money. It's same. Increase use of renewable energy resources, enhance use of energy efficient appliances, as I told you, like this. Not only star rated, I mean this smart inverter duty appliances one should look for, not for all, but for the equipment, for the appliances which are there to run over a considerable period. Continuously जो चलेगा, सुबह चालू हो गया रात तक, रात भर चलेगा, ऐसा. Use LEDs, solar appliances. Achieve higher power factor. Use smart inverter duty equipment. So that's all. I have touched upon few very interesting areas, but I didn't enter into that because those are quite elaborate areas, and in one particular session it is not possible to. So I have touched upon. So maybe at in future, whenever some specific on a specific topic on industrial electrical this thing. So I'll definitely be available. So this was more of a topic which gives an insight to what are the problem areas or the key areas where we should hit in industry and also in domestic, so as to release some energy. Yes, some because see, generation, we are enhancing our generating, but it is costly. Installing a power plant, whether it is a solar power plant and thermal fossil fuel power plant, leave aside the hydel, it's the costliest. You have it has to, you have to pay for it, and our government, India, is installing the capacity, enhancing the installing capacity in leaps and bounds. You just leave aside this to 2020 and there's a small dip again. We are back to our growth in the power sector, but at the same time we have to optimize the consumption. We have to minimize the consumption so that more energy can also be generated. I mean, with the same resources you can use more. Okay, so this is of tremendous importance, and particularly those very basic things, power factor में थे. हाँ, ये तो power factor तो कुछ समझ, तो बहुत सिंपल सा चीज है, लेकिन ये इसका implication क्या है, इसका महत्व क्या है, that is fantastic. So whether from VFD to generator static excitation, power factor is a unique thing. So okay, friends, I think I'm at the end of the lecture, and if you have some doubts or some queries, I'm ready to answer.
Thank you, sir. It has been really a fascinating and informative as well as elaborate session that you have shared for all of us. And I hope, especially our students from electrical engineering department, will greatly profit from your presentation, from your slides. Sir, with your kind permission, would like to move into question answer session.
Okay.
Okay. Sir, we have a question for you asked by one of our students. So, is the question visible to you, sir?
Yeah, what the question is, what will be our future scope in control, utilization, management of electric power?
Exactly, sir. Exactly, sir. Would you please answer this?
I think the topic itself, this is the title of the topic. So, future scope in any whether it is electrical power or any mechanical things, say hydraulics. Okay, so any area, any energy, the control, utilization, and managing that energy is of utmost importance, because we are using electrical energy to do the work. Okay, so until unless we control it, we can control it and we utilize in the best possible way and manage it through our state of the art technology, we cannot efficiently run the process. See, suppose I'm running an industry. Okay, I'm running an steel industry. steel industry is very big. Any small industry. Now, I am having. I know that my load is around say 20-25 megawatts. Say I'm running a small mill. Okay, 20 megawatt is my contract demand. So whatever product I sell market जो भी है और मेरा बिजली का जो खर्चा है उससे मेरा 20 मेगावाट का पावर जो कॉन्ट्रैक्ट डिमांड है और स्टेट इलेक्ट्रिसिटी बोर्ड का हर 4-5 साल में देयर इज एन एनहांसमेंट ऑफ द बिल. ओके, so my energy cost will also go up. My system, my mechanical system, also there is an wear and tear. So आज जो efficiency है आज से 6 महीना बाद 1 साल बाद efficiency will also fall down. So demand or the equipment failure will also be there. So until and unless I make my system an efficient one, and if I can't control and utilize the energy that is available, or the electrical energy or electrical power that is available to me, if I cannot properly utilize it, if I do not go for some improvement scheme like energy saving scheme, I cannot even fight the inflation, because cost of energy will be increased. So in industry, it is always there will be some improvement in the operational efficiency of electrical consumption or whatever. Operational efficiency of a motor means, of an equipment means that energy efficiency has to be affected. So until and unless you do that, तो आपका तो कॉस्ट ऑफ प्रोडक्शन बढ़ता रहेगा, है ना. अभी आज का दिन में आज जो एक मान लीजिए एक सीमेंट प्लांट में जितना टनेज का सीमेंट प्लांट आज है, आज से 10-15 साल पहले जो पावर रिक्वायरमेंट होता था, सेम प्रोडक्शन ऑफ सीमेंट के लिए प्रोडक्शन बढ़ भी गया, लेकिन मेरा ऑपरेशनल एफिशिएंसी बढ़ गया, मेरा इलेक्ट्रिकल एफिशिएंसी बढ़ गया, मेरा यूटिलाइजेशन इंडेक्स बढ़ गया, मेरा कंट्रोल इफेक्टिव और ज्यादा हो गया, और मैनेजिंग अगर हम बढ़िया से कर रहे हैं तो सेम पावर में हम ज्यादा सीमेंट प्रोड्यूस करेंगे, जो हो रहा है. सो until unless you enhance the control and management, you cannot beat the inflation and beat the product cost of production. Forget about the quality. क्वालिटी तो होना ही है, क्वालिटी तो बढ़ेगा. आप क्वालिटी को कोई प्रोडक्ट का एनहांस करना है तो आपको हर एक चीज में, एक प्रोडक्शन यूनिट का हर एक चीज में आपको प्रोसेस को आपको बेहतर बनाना है. बट only if you talk about electrical parameters or electrical power consumption and energy efficiency, if you can improve it, you can make it more economic, and which is the very basic things to run an industry. Okay.
Thank you, sir, for taking this question. Now we are at the end of this session and we have vote of thanks. I'll request our respected HOD. I'll request our Dean of Academics, sir, Sri Tanmay sir, to deliver the vote of thanks. Please, sir.
Thank you, sir, for your fabulous speech, which is very much informative to the student. The student likes your mode of teaching as well as industry orientation, and we are very much really extend my great thoughts to you for extending your heart welcome for this impact speech series. We are very much honored that you have been given the speech with your busy schedule. You have. Thank you, sir. Thank you from AIMP.
Thank you.
Sir,
It was a
it's
nice
very-
experience for me also, and fantastic arrangements.
Okay,
There was
sir.
not a single I think disruption. I think the slides have also was visible, and I was audible
Awesome,
all
awesome.
along.
All the things you have prepared very well for the student from basic level. This is the important of your webinar. You have just pointed out the primary notes that from starting from current to ohms, after that apparent power. I have just want to say that you have selected a very good example in the apparent power with a glass of drink,
Yeah.
apparent power, reactive power. We are very much thankful, sir. Okay.
Okay. Thank you.
Thank you, sir. Thank you for your informative and
Yeah. Wish you
brilliant speech.
all the success. I wish Asansol Institute of Engineering and Management all the very best. So I am sure that industry are going to get benefited by the students who will come out regularly from this, and with this kind of sessions will be of immense help.
Yes, obviously.
I think so, and
Sir,
personally,
actually,
I like the session, interacting with you all.
sir, in future we will extend our meeting for the offline also. We'll call you
Okay.
for the offline mode also because this time AICT has not permitted for the offline. May in future we will go for the offline
Okay. I like this classroom sessions very much.
classroom session. Yes, yes, yes. This is very
As,
more
as I told
important.
you at the very beginning, my first love is definitely academics. Although I was all along I was in the industry, but the type of industry that I served and type of job, I could always connect myself with the academics, because the type of service that I had to produce, I have to give. Okay,
Okay,
thanks
thank
a
you,
lot.
sir.
All the best.